All right, welcome back to our section on standard normal distribution. In our last video, we took a look at finding the area to the left of a z score under the normal probability distribution. In this video, we're going to take a look at values to the right, or areas to the right, areas in between two z-scores, and then areas outside of two z-scores. And again, we're going to make use of technology, and I will again link the code to the Python program that I'm using to find the areas. And again, if you have another statistical package that you use, whether it's specifically designed for statistics or a spreadsheet software, oftentimes have statistical capabilities in them. Feel free to use those. Again, I am trying to keep everything free and easily accessible to everybody. So whatever works for you, that's what I want you to use. So. All right, so in this example, we're going to find the area under the curve to the right of each of the following z-scores. And again, I strongly urge you to get a sketch of your problem to start with. So for instance, here we have z equals negative 0.25. So we want to sketch everything to the right of negative 0.25. Now, just to get a quick, back of the envelope calculation here, half the scores are below 0, the other half are above. So it's going to be at least 0.5 because we have everything to the right of 0 shaded. But then we have a little bit more in between the negative 0.25 and 0. So we should get an answer that's above 0.5. As far as how much above it is, that remains to be seen. But if we get anything less than 0.5, that means we made a mistake somewhere. Maybe we calculated the area to the left instead. Now, for a lot of statistical books that have tables and values in them, most of those values are coming in from the left. So we could figure out what the area is to the left and then use the complement rule. But again, we'll use the calculations that we have available to us. So I'm still on this program, haven't quit out of it yet. We're still working with z-scores, and we're trying to find the area. So select option 1. This time we're selecting the area that's to the right. So we're going to select option 2, and the z-score this time is negative 0.25, and there we go, 0.5987. So again, it was above the 0.5, which it should have been. So we get 0.5987 as our area. So the probability of selecting a z-score that's greater than negative 0.25 is about 59.87%. So roughly 60% of your values are in this green shaded region. Part B, z equals 2. So again, here's z equals 2. So not a whole lot of area here as expected because there's not a whole lot of values above 2 standard deviations from the mean. So let's go ahead and take a look at, again, we're dealing with z-score. We are the area that is to the right. Oops, I think I goofed up here, so that's okay. Okay, so there we go. Still z-score, so we're trying to find an area. So 1, and then we are finding the area that's to the right. And this time our z-score is 2. So we're finding everything to the right of 2 is about 0.0228. So 0.0228. So the probability of getting a value that's more than 2 standard deviations above the mean is about 2.28%. So not a whole lot of the values are above 2 standard deviations. All right, so when finding the area between two z-scores, the idea, and this is, we can take the area that's to the left of the higher z-score and subtract out the area that's to the left of the smaller z-score, and that'll give us our area between our two z-scores. So take this area, subtract this tiny area, and then you'll get the area that's in between. So notice that, to the right of 2, was not shaded, so to the right of 2 is not shaded. We're subtracting out this to the left of 2 here that they have in common, so this to the left of 2 is negative 2 rather, that they have in common is not shaded as well. That's the idea behind it. Again, looking at this, as far as this one goes, we can calculate the area between two values, option 3 here. But if you didn't have this available for whatever reason, like you were using tables in an old statistics textbook, then you would have to use this method here. So find the area of the curve between the given z-scores, -1 and +1. So what's this area between here? So what percent of our data is within 1 standard deviation of the mean either way? So for this one, we are working with z-scores, and we are trying to find the area. And this time we're doing the area between two values. So we're going to select option 3. And lower z-score is -1. The upper z-score is 1. And we have about 0.6827. So 0.6827. So our probability of selecting a z-score within 1 standard deviation of the mean is about 68.3%. So about 68.3% of our data values are within 1 standard deviation of the mean. For -2 and +2, I'm just going to speed things up here. Entering in -2 and +2 like we did -1 and +1, you get about 95.45% of your data within 1 or within 2 standard deviations of the mean. And for -3 and 3, that's a very high number. It's about 99.73% of your data values are within 3 standard deviations of the mean. And as far as between 1 standard deviation, 2 standard deviations, and 3 standard deviations, in statistics, we have what's known as the empirical rule, sometimes called the 68, 95, 99.7 rule, which states that about 68% of your data is within 1 standard deviation of the mean. So what we saw with z equals -1 and 1. About 95% of your data is within 2 standard deviations of the mean. So between z equals -2 and z equals +2. And then about 99.7, so just about all of your data values, just about all, are going to lie within 3 standard deviations of the mean, which is -3 to +3 for our normal distributions here. So we can use the complement rule to find the area under the curve not between 2 z-scores. But again, as we've seen, we also have the ability to find the area outside 2 values. But again, if you're not using this program, if the program you are using does not have the ability to find it outside, you have to find the area between and then use the complement rule. So here would be outside of 2 standard deviations, which is 1 minus the area in between. So about 100% minus 95%, about 5% of the total values would be outside of 2 standard deviations. So about 4.55%. If we wanted to see this using this one, we'd select z-scores, trying to find area. So 1. In the next video, we'll look at selecting option 2 here. This time we're finding the area outside, so 4. And the lower z-score was -2. The upper z-score was 2. And there's our 0.0455 of our total values are going to be outside of 2 standard deviations from the mean. All right, that about does it for this video. Thanks for watching.